Hey there, this is my interactive advanced concept for week 2. My name is Andrea. I have all my materials gathered here. I already poured the water in the vase. Well, I dumped out most of the water that came in the vase. So this is my purified water. Okay. This is my purified water. And then I have some vegetable oil, some food coloring, and some Alka-Seltzer. It's the generic brand, but I checked out the um, drug facts, and the active ingredients and everything were all the exact same. So I pretty much just saved like $4 by getting that. And that's what I'm going to use here. And okay, so we're going to do the lava lamp, and I'm going to start adding vegetable oil to the water. And it looks like it's mixing, but then it separates out. And I'm going to go a little faster there. Alright, so I'm going to leave a little bit of space so that there's some room to work with. And I'm going to wait for that to separate out because, or they will separate out because of the density of the two the combination of what I'm doing. So I have water and vegetable oil. Water is more dense than vegetable oil, so the vegetable oil is going to go to the top. The water is about 1 gram per milliliter density, and this is about 0.92 grams per milliliter. So that's pretty much separated out. This should pretty much just all be water at the bottom. It looks tinted though because of the vegetable oil color, and I'm on a black surface, so it's kind of hard to tell. Alright, now I'm going to use this red food coloring, so I'll do about 10 drops. Maybe a few more. I think my drops are small. Okay. And now the food coloring is water soluble, so it should be about the same density as the water. I'm looking at the ingredients, and there are what seem to be alcohols in it, which I know that the alcohol density of alcohol is lighter than water too. That's what I'm almost thinking is happening up here at the top of this oil, is that it has to do with just the varying density, but it is getting to the bottom, so you can see the red. I kind of want to make it happen faster. The water is slowly turning red. There's quite a bit of food coloring still at the top there. There we go. Move that out of the way. And it's still floating down. So now what we basically did is the water and food coloring are going to be one homogeneous mixture. So I'll put that away over here. And this out of the way. And I have my Alka-Seltzer. It's pretty well mixed there. It's still kind of mixing down into the water. It's still floating on the top a little bit, like suspended in with the bubbles of vegetable oil. But I'll open up the Alka-Seltzer in the meantime. And so Alka-Seltzer, looking at the chemical formula for it, is basically baking soda and acetic acid. So it's not going to react with the oil, it's going to react with the water. So what we're going to have is our chemical reaction with the water and the Alka-Seltzer, like I said, which is baking soda and acetic acid. Oh, that was a good big clump of color that just went down. Okay, so I'm going to break it up, and we're going to add it in, and watch what happens to the water. And so we have these red bubbles, but they pretty much are just, it's all water. So the red is actually water. It's not anything separate. It's not, we have one little food coloring piece that didn't get into the water yet. But for the most part, we can see um, it looks like a lava lamp now. It's working pretty quickly, especially right there where the Alka-Seltzer is still being absorbed. And so what's going to happen is, there's actually some Alka-Seltzer there. It's going to keep reacting until the Alka-Seltzer runs out. We still have plenty of water and we still have plenty of vegetable oil. So when the baking soda is reacting with the water, it's creating CO2. That CO2 is making the water move up and mix in with the oil. And when that Alka-Seltzer runs out, everything's going to calm down again. The gas is going to escape through the top, and the water is going to settle back down. And that would mean that the limiting reactant is going to be the Alka-Seltzer, because there's going to be no more CO2. It's all going to have left out the top of the vase. And you can see that, I mean, it's slowly calming down. If I had put a lot more Alka-Seltzer in there, it would continue to react, but it's already settling down. So you can see that there's the water going right back from the oil into its own mixture there. You can see there's still stuff floating around, but I think that's just from the remnants of the Alka-Seltzer. So yeah, it worked for a very short period of time. I think that if I added more Alka-Seltzer, it would continue to go for probably a while, because that would just take more time for it to react. Even though the Alka-Seltzer is the limiting reactant, you could probably still keep it going for a while, because I think that there is plenty of water and vegetable oil in comparison. So apparently if you let all of the air escape and let the reaction completely stop, you can put a cap on it and then just use it again at a later time.